Okay, so today we're going to talk about exponential functions. We are going to talk just basically about all the important parts of exponential functions and kind of what they look like. Next week we will be tackling transformations, and so you'll kind of understand a little bit more how we can get the special parts from an equation versus just looking at a graph. Okay, so I picked just 4 basic exponential functions. The first one is 2 to the x. So some important features of this function is that your domain is negative infinity to infinity. It's really important to know that your domain of every single exponential function, no matter what, is going to be negative infinity to infinity. The range will vary depending upon how your function looks. So range is still your bottom to top or your lowest y value to your highest y value. In this case, our lowest y value, it gets really, really close to 0. In this picture, it does look like it's touching 0, but it's not. And we'll talk about that here in a minute. So our lowest y value, we're going to say is 0, but we're using a parenthesis because it never ever touches 0. It just gets super, super close to 0. And then it keeps going up forever and ever and ever, so to infinity. So our range in this function is from 0 to infinity. Our y-intercept is where it crosses the y-axis, and this graph happens to cross at 0, 1. And our asymptote is a horizontal line, the y equals 0, which is also just the x-axis. So again, we get really, really close to this x-axis, but we never ever touch it. That's what an asymptote is. And I'm going to open up Desmos here to kind of help explain that a little bit more. We can kind of zoom in a little bit in Desmos to see it a little bit better. So if I have y equals 2 to the x, so if I zoom in here, and you can see it's getting really, really close, but it never ever touches. And I can keep zooming in and keep going over. And again, it gets super, super close, but it's never ever touching it. And it'll just continue to keep getting closer and closer. So exponential functions have an asymptote. It is a horizontal line in this case. And it just means that we get super, super close to it, but we never ever touch it. Alrighty. And we talk about exponential functions can either be a growth model or a decay model. Since this one, as you look from left to right, is increasing, and it keeps increasing forever and ever and ever really, really fast, it is a growth model. Alrighty. So now if I change what we're multiplying by, we have this 1/2 instead of a 2. We have a lot of the same important features, but there's going to be one little tweaky change. So the domain is still negative infinity to infinity. Our range is still 0 to infinity. Our y-intercept still is at 0, 1. Now, and our asymptote is still y equals 0. Now, the thing that changes here is that as we look from left to right, our graph is always decreasing. Since it's decreasing, this is going to be a decay model. In a couple weeks, we'll actually be putting some of these growth and decay models, like we'll actually be coming up with equations and figuring them out based on situations. So we will be applying this in a little bit. Alrighty, so we can also reflect both of our functions. So when we reflect our functions, it does change our y-intercept and our range a little bit. Domain, though, as you look from left to right, still negative infinity to infinity, all those x values. Now our range, as we look from bottom to top, we start here at negative infinity, and we get really, really close to 0, but we never ever touch it, which is why there's a parenthesis there. So our range is from negative infinity to 0. Our y-intercept, it now crosses at 0, negative 1. And the y-asymptote is still y equals 0. And if you noticed, our asymptote here matches that y value on our range as well. Okay, so we can also reflect the 1/2 to the x. So a lot of things are the same. Your domain is still negative infinity to infinity. Now our range goes from bottom to top, so from negative infinity to 0. The y-intercept is still at 0, negative 1, like it was for the other one. And the y-asymptote is still at y equals 0. Okay. I'm going to come back here for a second video for the last examples.